Download this code from codegive.com, link in the description below. OK, let's break down the concept of a 0 million chance to win, which is really 0% or impossible, with explanations, code examples, and explore how such scenarios might arise in programming and simulations. We'll also touch on related concepts like probability, impossibility, and how to represent them in code. Understanding 0% probability, impossibility. Asterisk probability basics. Asterisk probability quantifies the likelihood of an event occurring. It ranges from 0, impossible, to 1, certain. A probability of 0 means the event cannot happen under the given conditions. Asterisk impossibility in reality versus code. Asterisk in the real world, absolute impossibility is rare. Things that seem impossible might just have an incredibly low probability, example being struck by lightning twice in a row. However, in the deterministic world of computer programs, impossibility can be definite because we define the rules. Asterisk why explore impossible scenarios in code? Asterisk error handling. Asterisk we often design programs to handle unexpected or impossible situations gracefully. For example, if a user enters invalid data, we might trigger an error message instead of allowing the program to crash. Asterisk testing and edge cases. Asterisk it's important to test how your program behaves when presented with edge cases, including impossible inputs. Asterisk logical constraints. Asterisk you might want to explicitly enforce certain rules that make some outcomes impossible within your program's logic. Asterisk simulation and modeling. Asterisk even if an event is theoretically impossible in the real world, you might want to model it as impossible in a simulation for simplification or to focus on other relevant factors. Representing impossibility in code. Let's look at some examples in Python and JavaScript. You can easily adapt these concepts to other languages. Python. Explanation of the Python code. 1 impossible _ event, the key is the limited input range, 1 to 10, and the specific winning number, 42. The user can never enter 42, making it impossible to win. 2 create _impossible_ function, this function will always return false. Therefore, the if statement will always evaluate to false and execute the else block. 3 demonstrate _impossible_ list membership, we check if a value, 999, exists in a list that does not contain it. The if condition will always be false. 4 handle _0_ probability, this explicitly sets a success variable to false. The if condition will never be met. JavaScript. Explanation of the JavaScript code. The JavaScript code mirrors the Python examples in structure and logic. It shows how to create scenarios where a condition can never be met, resulting in a 0% chance of success. The key ideas are the same. Asterisk limiting input possibilities. Asterisk creating functions that always return false. Asterisk checking for the presence of elements that don't exist in an array. Asterisk using Boolean variables that are always false. Advanced scenarios and error handling. 1 exceptions and assertions. Asterisk in more complex programs, you might use exceptions or assertions to explicitly signal when an impossible condition has been reached. Asterisk Python asterisk. Asterisk JavaScript asterisk. In these examples, attempting to calculate the average of an empty list is considered an impossible, or, at least, an invalid, operation. The code raises an exception to signal this. 2 logical fallacies asterisk. Sometimes, an impossible outcome can arise from a subtle logical flaw in your code. Careful testing and debugging are essential to identify and correct these errors. Important considerations. Asterisk context matters. Asterisk the concept of impossible depends on the context of your program. Something might be impossible given certain input constraints but possible under different conditions. Asterisk real world versus simulated impossibility. Asterisk remember the distinction between true mathematical impossibility and situations that are simply highly improbable in the real world. Your simulation might treat highly improbable events as impossible for simplicity or performance reasons. Asterisk robustness. Asterisk even if you believe a certain outcome is impossible, design your code to handle unexpected situations gracefully. Defensive programming practices can prevent crashes and ensure the reliability of your software. In summary, understanding how to represent and handle impossible scenarios in code is crucial for building robust, reliable, and well-tested software. By explicitly defining constraints and handling edge cases, you can create programs that behave predictably even when faced with unexpected or invalid input. Remember that careful planning, testing, and error handling are essential for dealing with these situations effectively.